All right. Next, some more complex fractions, more fun. What we can do, rather than just making taller and taller and taller stacks, we kind of briefly joked, talked about how much fun that would be to do, leaving it as sort of a challenge exercise for you guys. The other thing we can do is start to just sort of essentially just like throw little micro problems on the tops and bottoms of our fractions. Let me sort of show you what I mean. We could take 5/3 minus 1/4 and then stack it over 9/10 plus something like 14 over 15, right? So essentially what we're doing is we're making a fraction where we've got right, an arithmetic problem, a fraction arithmetic problem, both in the numerator and in the denominator. So this could be fun. You have a couple different strategies. I think what we'll maybe do is kind of stick with this one example and then just sort of run it a couple different ways. So our first solution our first option is going to be essentially to just do this by attacking it almost like it's two separate problems, right? We're just going to sort of do a numerator problem, 5/3 minus 1/4. Obviously, each of these, the sort of key first step is you need an LCD. If I'm working with 3 and 4, my only real option there is going to be 12, right? I mean, those numbers are sort of small enough. There's no overlap there. It's not really so much trouble to just sort of multiply them by each other. It's the first time that they're going to overlap. So then this would just sort of become, right, 20 over 12 minus 3 over 12. So that would leave us in the numerator with something like 17 over 12, right? So this is sort of our new top fraction. So we're not doing anything with the bottom just yet, right? We're just sort of taking these two apart and dividing them, right, into sort of two totally separate universes, right? We'll do the same thing. We'll sort of pull our bottom values down here, 9/10 plus 14 over 15. Common denominator, LCD, for 10 and 15, those guys will meet up at 30. I'm trying to just save a little bit of space on the page. By all means, sort of take as much time as you want just to sort of verify that the common denominator there is 30. If you make a list, right, 10, 20, 30, 40, 50, 60, 15, 30, 45, 60, right, you hit 30 almost right away. It's obviously pretty clear 30 is going to be a multiple of 10. You definitely don't need to go all the way up to, right, 10 times 15. You don't need to go all the way up to 150. That would really be a much bigger value than what you need. This becomes then, right, 3 and 3, 2 and 2. So this becomes for us 27 over 30 plus 28 over 30. This is going to be in total, how much? 27 and 30, that's going to be what, 55? Or not 27 and 30, right, but 27 and 28 would be 55, all over 30. Okay. So what this means is my sort of overall value, right, becomes, so rewritten, let's try to keep these colors consistent. So this becomes 17/12 divide by, what's my other color, blue, 55 over 30. Okay. It is what it is. I don't think we're going to have tons and tons of values in common here, but that's okay. We're not necessarily trying to have this cancel all the way down to a whole number or anything. Once we have it set up in this way, we're essentially just on to the same things that we were doing before, right? So then this is just 17 over 12, divide by 55 over 30. Flip and multiply, 17 over 12 times 30 over 55. Okay. What are we working with here? Anything here that's going to cancel out? Not tons and tons of stuff. We could do 5 and 6 here. 2 and 6. Oh, here's some other stuff actually. 17 is prime, but 55 is 5 times 11. This is going to clean up even a little more than I was expecting, actually. I wasn't seeing it first, right? 6 and 6 is kind of what I was looking at initially, and I kind of overlooked that 55 over 30. We even could have gone back here, right? This would be 5 times 11. This would be 5 times 6. The 5s and the 5s here will cancel. This would really be 11 over 6. That would have been a smaller number for us to even start with. If we don't catch it at first, that's totally fine. We can get these 5s a little bit later on. So this is going to actually be what? 17 times 1 over 2 times 11. So this becomes for us 17 over 22. Something kind of like that. So this is an option, right? This is sort of one way to go about this solution. If it gets us to an answer, you kind of just, put your blinders on a little bit and do this sort of one piece at a time, right? Just do everything in the numerator, everything in the denominator. You go from there. However, not the only way to do it. Let's do a second option, and this we're maybe going to have sort of like a 2a and a 2b. This sort of multiple ways I've explained this in the past. So, both of these options rely on find an LCD for all of your denominators. So don't just look at the top fractions and then the bottom fractions. The idea is to actually look at all of them together. So that is for me, right? I want an LCD for 3 and 4 and 10 and 15. I want sort of all of those together. That might seem like tricky. that might seem extremely difficult, but it should be okay, because the idea is to just sort of take it one pair at a time, and we sort of know half of this already, right? We know 3 and 4 would sort of sync with 12. What we're going to do then is compare 10 to 12, right? The LCD for sort of those two. In theory, right, 10 times 12 would be 120, but there's definitely overlap here, right? 6 times 2, 5 times 2. The overlap here would be 2, so we could actually use 60 as an LCD for both 12 and 10. And then the last step would be to sort of compare 60 and 15, and it turns out actually 15 times 4 would be 60. So we can use 60 as an LCD across all 4 of these fractions. So you say, okay, that's great. Now I have bigger numbers to work with, I guess. Like, huzzah. And so there's 2 strategies here. What I'll give you guys, maybe what would come more naturally would be then to sort of, okay, let's rewrite whenever you find a common denominator. The idea is to sort of then rewrite all of your fractions with that as your denominator. So let's rewrite all of these guys over 60 instead. So how am I going to get from all these things to 60? Well, 3 would be times 20, right? 20 and 20. 4 would be times 15. 15 and 15. 10 would be times 6, 6 over 6. 15 is going to be 4 over 4. So what happens here is I get a new version of all this stuff. This sort of, again, as it sometimes does, temporarily seems extremely bad. This is going to be a hundo over 60. This will be minus 15 over 60. This is going to be all over 6 times 9, 54 over 60 plus 4 times 14. 2 times 14, 28. So 4 times 14 must be 56 all over 60. So conceptually, the idea here, and this is, maybe playing a little sort of fast and loose with the math, is that if you have all four fractions, all of them are over 60, right? So all of the denominators are totally in sync. What we're going to do in a very sort of not rigorous way is we're just going to cancel them all out. The idea here is that if all of your numbers are over the same value, everything here is over 60, the 60 is not really having any impact on the final solution, right? Everything is sort of scaled to be over 60. That means the 60s are kind of redundant, because if everything is over 60, then the only thing that really is having an impact on your final values is the numerators. So the idea is you're going to just sort of cancel all of these out, and so you're going to take yourself from 4 fractions down to 100 minus 15 over 54 plus 56. You're just going to kind of take yourself to write kind of one fraction, but sort of working with whole numbers instead. This is going to leave us with only the best values, 85 over 110. Everybody's favorite numbers to work with. These are both divisible by 5. This would be that classic, everybody knows, 17 times 5, and then only a little bit more obvious, 22 times 5. And this is pretty good. 5s cancel out. This leaves us with the same value we had up top, right? So that's a pretty good sign that we're sort of ending up in the same place. So one option here, right, is rewrite everything with that same common denominator, and go from there. You can get, I sort of said we have kind of a 2a and a 2b here, to be or not to be. Always a not particularly funny joke. So the sort of 2b option, right? This is kind of 2a, right, is over here. 2b would be start with the same thing, 5/3. I'm just going to do this fast because we essentially have done most of the setup already. The idea is you use that LCD for all 4 of your values again, right? So 60 is our LCD across all of the denominators. And so rather than rewrite everything over 60, the other option here, and this is sort of how the book explains it, is that you can actually multiply everything by 60 over 1. All this is going to do, this is a little bit more of a proper math way to kind of get us to the same result that we just had. So for example, right, 4 and 60, this is going to leave us with 15, 3 and 60, this is going to be 20. So we're going to get 20 times 5 over 1, right, minus 1 times 15 over 1. That's going to be our 100 minus 15, just like we had before, right? 10 and 60 is 6, 15 and this is 4, so that's going to be, right, 6 times 9 over 1 plus 14 times 4 over 1. This gets us to that same thing we had again, right? 54 plus, what do we say this was? 56. So we get 85 over 110, just like we had, which is going to simplify down to our 17 over 22 again. So same answer, you're just sort of going through the process in a slightly different way. So up to you.